Good morning and welcome. Today is day number 5, and we will see some uh, particular connection on the external area, like TOC or BIVAN, where TOC means Technical Operation Center, and some related features, including also the fly case. And for the last one, we have edit suite and archive system. I have prepared some slides um, where you can see the connection between the terminal point of the TRIAX connector and from the other side, the terminal point of this connector inside in the pre-roll, in the garden, and also in the minaret and the esplanade. As you can see, so in some days ago, I told you that the tracks connection are point-to-point connection. So we have just a cable from the technical operation center to a wall box, wall plate, or floor box. But itself is just a cable without power, without anything. It is used. So tracks, it's an old technology, means that the modern technology it's through SMPT or fiber, or the really last one it's over Ethernet. But there are a lot of device and OB-WAN and other things equipped with tracks. That means tracks has been installed to have compatibility with the old technology. In this case, tracks, let's imagine that you have an OB-WAN with equipped with a tracks camera. Then you can connect your OB-WAN to any point on the terminal panel here, and then you have a table which give you the position of each connection in the system. Let's say on this is panel 1, we have position 1, and is it this one? Then we have this one which is connected on column A1032, and column A1032 is in the pre-roll, and is it this one? The red letter MP11 or MP14 is just a technical indication. I mean, it's always a track connection. It's an internal indication which says us this is a 14 millimeter triax diameter, and this is 11 millimeter triax diameter. But from a functional point of view, nothing changed. It's still always the same. And also the connector are standard. Then you can connect anything here independently if the cable on the rear is 14 or 11 millimeter. Um, okay, this is the first panel give us 6 position corresponding to the 1, 2, 3, 4, 5, and 6. The first 6 column in the pre-roll, considering the entrance in this point. The lateral entrance, of course, not the main one at the center. Um, the second panel is almost the same, but there is a particularity that I have to show you because it's very important. If you look at uh, this column A1016 as a tracks connection in position 5, that means is this one. But if we move on the next slide, we have also the same column with another tracks connection. This because the column is this one, and on the column there are two wall plate, one in this position and one on the other side, 180 degree on the other side. This is a special requirement that they ask to us, and we have installed two plate on the same column. One is, as you say, column floor box number 5, and the other one is column floor box number 7. But really, on this column, you may connect two tracks on two different sides, and you have two tracks with destination. One is 5, and the other one is tracks 1 on the second panel. So, again, we have MP11 means the tracks connection is over 11 millimeter cable, but from the functional point of view, it doesn't matter. It works in any way. Then we have 6 column also here, including wall box 12 on column A1019. Yeah, one thing it's important. On these column, we have also a Shotoku PTZ system. Means that on the same column, we have already a camera controlled by a PTZ system by Shotoku. Shotoku system is completely independent from tracks. That means Shotoku system works with GMA equipment, video switcher, video router, and so on. But tracks is point to point. That means tracks is connected to OBVAM. There are some columns like A1028 or A1031, which are on panel number 3 without camera. They have just a wall plate equipped with SMPTE, fiber, power, triax, and TP12 to connect maybe the fly case. But on this column, there are not camera installed. That means if you want to have a camera here, there are two-way or three-way. SMPT connection to the EQR1, tracks connection to the OBVAN TOC, or NTP12 with the fly case to the EQR1. We have also some camera on the Esplanade, or better, we have some tracks on the Esplanade. And what you can see here are the position of the wall box into the esplanade. 17, 18, 19, and 20, uh, both four connection are at RDC level, ground level. These connection in the triax are in the esplanade, but at level 020, this one, and level 030, those two, at the third floor into the esplanade, just if you want to mount a camera on top. Then we have also two triax connection also in minaret inside where the rack control rack of the minaret is located. Of course, there are no space to put camera outside because there are maybe on the balcony you can put it, but the connection are inside that you need a cable to extend your camera. One of the uh, yeah, let me check. Yeah, okay. When you find MP11 here, and here is written 14, means that in the middle somewhere we have a junction between the two cables, 11 millimeter and 14 millimeter. If you remember, in the past I have told you that for some technical reason we have used 14 millimeter for very long path and 11 millimeter for the shorter one. This is the case where we have both 11 and 14 millimeter joined together to reach the position. We have also some position in the garden. We have 6 position in the garden, which is the last position, where we have a wall box, and into the wall box we have tracks, SMPT, fiber, and power. Of course, the tracks connection allow to power up the camera and send and receive control, video, and commands. There is one thing that you have to consider. So, if Marco, please, can you switch on the whiteboard? Yeah, thanks. So, yesterday, if you remember, I told you that we have talk in this position. Then we have EQR1 more or less here. Then we have the building and the pre-roll is inside here more or less at the RDC level. Then we have minaret here. Okay, if and then there is a parking here. If the obi-Wan are in the parking here or here, and you want to connect the triax from Technical Operations Center to the obi-Wan, maybe 30, 50 meter triax is enough. But if happened the last time you want to put your OB-WAN in this position and you want to connect to the talk. If you remember, we have 500 meter or more, maybe 600. What does it mean? That let's considering in HD the maximum distance that you can reach through the triax, about 1500 meter. We have already some distances built in, because if you have to go to the pre-roll, it's just here, maybe 300 meter. But if you have to go to the esplanade at level 030, this one can be already 800 or 1000 meter. That means if you put your OB-WAN here, you have to add this distance, and it may be possible that you reach this limit, especially if you are using this triax, 8mm triax, because we have three different sizes. We have 8mm, 11mm, and 14mm. A triax 8mm can give you less distance available instead of 11 or 14. And if your OB-WAN is equipped with 8mm, it may be possible that this distance will increase the attenuation respect the very distant point here. This is to be keep in account when you decide what you have to do and where the position of your OB-WAN should be. Any question? Okay.
Yes, Maurizio. Good morning.
Yeah. Good morning.
Maurizio, please, in this case, there are any choice to use an extender for triax like Ethernet?
Um there are some devices from Sony which allow you to extend triax over fiber. Uh, I don't know if you can rent it in Algeria, if they are available in Sony Algeria or some other place, but we don't have in GMA.
Also for Sony, it's triax fiber. There is no triax.
What do you
Extender,
mean?
not transceiver.
No, there are some devices which allow you to transform the triax in fiber. Then you can arrive here and transform back the fiber in triax.
This is a transceiver. I'm speaking
Yeah,
about an extender.
an extender of the triax? No, no,
Okay.
no.
Maurizio, please, I have another question. You
Yes,
spoke about old technologies using triax and the new technology using Ethernet. In our
yeah.
case, if we want to use Ethernet, what will change according to the equipment? It just to add an encoder, decoder, or what we should do?
You
Just an
can't.
idea, general idea, please.
Yeah, but you cannot, because the video over EP is a complete new technology that cannot be. It's a completely different thing. It's a very latest technology, and in some part it's already under test, but there are already many installations with video over IP, where your signal becomes an EP packet. And then, for instance, the video router, as we know now, if you remember, I told you the video router is essentially something like a matrix where we have some input and then we can close some switches and then we have the output. Well, the under IP, this is not true because source and destination, they have an IP address. Then your video, your packet, which has associated an destination address, the matrix is not a real router matrix, but it's a series of IP switches dedicated with a special firmware inside, and it is a completely different and new technology. There is, I mean, it's can be mixed, but you need another control room. You need a completely different type. For instance, the video switcher, the VXS 7000, can be equipped instead of the backplane with the BNC 12G, can be equipped with the backplane with SFP EP, video EP. Internally, it works the same way, but the main interface is video over IP. But is the rest of the system, which is completely different. There are no distributor. There are no video router. Everything is working over a series of switches with extremely high performance. Because you can imagine also if you are in HD, each stream is 1.5 gigabit. Live is not a computer transmission. So let's say the big difference, just a second. No, it's better if I do that. Wait. Okay. Okay. In a computer transmission, in a computer connection, you have PC1, then you have maybe a switch, and then you have a PC2 or a server, let's say server. Over TCP IP, this computer sends a request to the server, and the server will answer to this request. If the computer sends a request to the server, and the server says, okay, yeah, I have received something, but I have not understood exactly what do you mean. The server can send back a packet which asks to retransmit the request or the data, because the data are arrived corrupted. In video, this cannot happen because video is a constant flux of data, because you want to see the picture live. That means what happened is you have your camera here, SFP, you have a big switch with a very, very high bandwidth, and then you have a video switcher here, XVS. And you have to be sure that in any condition, if you use one camera or if you use 20 camera, the switch in the middle are able to process such an amount of data, and of course are able to send those requirements to the XVS, and the XVS is able to give you an output. If the camera sends something, the XVS cannot ask, please, can you send me back the frame because I have not understood exactly, because you lose time. It's impossible to see on the video. We are talking about signal not compressed. This is the latest technology for video, but really the equivalent of the EQR1 or EQR2 is not a technical video equipment room, but it's a data center equipped with a really, really high performance device. There are a lot. This kind of configuration allow you a lot of flexibility, because, for instance, let's imagine you are a private television. Then a private television, you have your electronic program which says, well, maybe in the morning, in the morning at 8 o'clock we have news. At maybe 9 o'clock we have a documentary. But at 8:30 we have a commercial. All these events are stored in a sort of a text file which send the command to, we can call it director, and the director, which is a software, it's a very complex software, send all the controls to the old device inside your structure according to the program. At maybe 8 o'clock, director send the command to the switch, and it says, okay, bring camera 1 and 5 and connect camera 1 and 5 to the video switcher. Then the output of the video switcher goes on the transmission on air. At 8:30, directly says, okay, do not connect camera 8 and 5, but connect player number 1 to the input of the switch and put on air the commercial. then we are here, and said, okay, it's 9 o'clock. Use player number 3 to send commands to the switcher, and the switcher put on air the documentary. So it is a completely different approach. All the tasks that normally are performed by human, in this way, more than 80% are transferred to the system. Of course, behind the camera there is always a man or a woman here. On the video switcher there is also always the operator, but the operator does not make any connection or doesn't care about connection, because the video switcher itself is prepared, controlled by the director for the next event. This is a completely new philosophy, and require a new complete approach to the system, and some way in the next year, in the next 5-10 years, will be the future. Is it clear?
Very clear. Thanks a lot, Maurizio.
No problem, no problem. If you need some more information, because it's a very interesting field, it's a very, very interesting one, you may check on the SMPTE site, and you can find some document. And also SMPTE will organize a webinar and on some webinar you must subscribe SMPTE, but there are some webinar free that you can are allowed to participate just under registration without any fees. I suggest to you to check that, because it's very, very interesting.
I will.
And of course, is the future.
Of course, I will. Thank you.
Okay. So, please, Marco, can you switch back? Okay. Now, please remember that if you connect, maybe if you have your OB-van so far away from the talk OB-van and you add the 500 meter, it may be possible that you can use camera within the prayer hall, but maybe you cannot use tracks camera on the wall box 28 or 29 in the garden, because it's so far away, respect the triacs installed in the prayer hall. Then take in account this one, because you said, oh, but this camera is working with it, is not working with the triacs there. Yeah, because if the distance is so far away, you cannot use it. Simply you don't get any picture. Now, in the talk environment, we have a micro NUHD video device. So, micro NUHD, we have already seen this kind of device. In that environment is used as general purpose video interface. That means all the connections are reported from the micro N on the video patch equipped with BNC, traditional BNC. So um, it may be possible to connect directly the micro and UHD, but the micro and UHD has a micro BNC, which are not specific to use it to attach and detach cable continuously. This is the reason why we have a fixed connection between these micro BNCs to a patch with the BNCs, real, uh, the big one, and then this is the external of the patch. And on this side, you can connect anything you want, a local monitor, a local telecamera, or an OB-WAN. Normally, OB-WAN, they have a lot of connection on the rear, tracks connection, but also BNC connection to receive and send a signal. Then, this is a way to connect the BNC's video from the OB-WAN or to the OB-WAN. These are inputs and these are outputs to have a signal. Maybe let's say you're doing an event and then you
Mauricio,
have
please,
some
your
tracks
microphone.
camera connected.
Mauricio, can you hear me?
Hello?
Thank you. Yes,
Okay.
it's better.
Let's say, imagine you have um, some tracks connected and you have some camera maybe in the garden, in esplanade, or in the prayer hall. The signal from the camera arrives directly to the OB-WAN. Then into the OB-WAN there should be a video switcher, and then you prepare anything you want because you have a direct signal. But at the same time, you need to use or not use for the event, but to have a control inside the prayer hall, and you want to see the local camera to see the people what they are doing because you have to instruct your operator on how to move the TIAX camera. Well, through the system MediorNet, you may have the 7 camera in pre-roll on 7 BNCs here at the output and connect those 7 BNCs to your OB-WAN to 7 monitor, and then you have uh, a direct watch on what happened inside through the local camera. But you don't use the local camera for the program, just to check it. Your real program is coming from the tracks. So this is another way uh, in which you can mix the two environment, you know, using the local as a control monitor and then a triax that you install with your camera as a program. Uh, Together with the micro N UHD, which can work at 12G and HD, we have a Compact Pro HD system which can manage 4 video input and 4 video output. Again, also this one is connected over a BNC patch. Then you may have you can connect everything here. You can destroy this patch without damage the system here. So your video in goes on MN Pro, and from there goes on the MediaNet network. So everything is in TOC OB-WAN is connected through the MediaNet network. This is partially true, and we see why later on the schematics. But just as indication, consider that the system works basically on MediaNet. And there is one thing important. Marco, please, can you... No, just a second before. Look at this reference out on the slide. Okay, take in your mind this reference out. Now we will see on the drawing what happened. Please, Marco, can you change on the drawing? Yeah, thank you. So, if we are, okay, let's say this is Obi-Wan from national television. Now, we have a triax which goes to talk, and then from talk there are already installed triacs which are going maybe on column 7 in the pre-roll. Well, if I put a camera here, I have my signal which goes back to the Obi-Wan, and into the Obi-Wan there is a video switcher. Let's say I have another camera, maybe on wall box 22 in garden. Well, this camera send back triax, and the triax is connected to the Obi-Wan. In this case, as I told you before, triacs are just a pieces of cable, are not, how to say, active elements. They are just pieces of cable. What does it mean? That the Obi-Wan has its own internal SPG, signal pulse generator, with this pulse generator black burst, or call it also reference. You will synchronize everything it's inside the Obi-Wan, but through triacs, this reference will arrive also to this camera and that camera. That means those two camera, or 3 or 4 or whatever, whatever number, is synchronized with the switcher inside here. Then everything is working fine. But let's imagine we have a different scene, a different configuration. We have an Obi-Wan not necessarily from national television, can be Al Jazeera also, maybe can be anything, can be a BBC. We have a triax connected to the talk, and then we have a triax which goes again to the column 7 in the pre-roll. We have another to the wall box 22 in the garden. And then we have the tracks here. But at certain moment, we can say, okay, for column number 5, I want to use the internal camera here. But this internal camera receive a reference from AQR1, not from OBVAN. This camera, through MediorNet, just send video here, and then maybe you have a BNC here connected to a BNC inside, and you need just one camera. But this camera is referenced by AQR1, not by the SPG inside the OBVAN. This is a very simple case. That means if your switcher inside has a frame synchronizer on the input, it's easy for your switch synchronize this source to the internal. Synchronization works in this way. It's just it works differently, but just to have an imagine in your mind, you can imagine in this way. There are two memories, let's say to RAM. Video arrives and video line 1 is written. And this memory is written with the synchronization from this video. Then the contents of this RAM is transferred on the second part of the RAM, but this RAM is read out with the clock from the SPG inside the OBVAN. And of course, when you have written the contents inside here, if you read the contents with the clock which is locked to the OBVAN, to the SPG OBVAN, your output is sync with the OBVAN. A frame synchronizer works in this way normally. But there is a problem. Every frame is 1/25th of a second. That means you have to wait 1/25 of a second to write down this one, then move instantaneously everything there, and then you have time to read it back. That means the delay between live video and the video output at least is 1 frame. What does it mean? That every frame synchronizer that you put in the middle add a delay. Always. Cannot do in other way because you have to write at certain speed and read it at another speed, which is determined by this clock. One frame is not so important, of course. But if you have some events where one frame is maybe in sport, let's imagine in sport, one frame is such a long time. That means it's always better if you can do not use frame synchronizer, but use the external reference correctly. On the MN Compact Pro, we have some sync out. How to use it? Well, let's imagine the MN. I will use another color which is better. Okay, this is a blue color. Then we have the MN Compact Pro. Okay, let's me do back my computer. Okay, Compact Pro. So the Compact Pro has 3 reference out, but these reference out are locked, of course, to the EQR1 reference, which arrives from GPS to SPG and so on. If you remember, we have already seen the synchronization, how it works. This means this output it's synchronized with EQR1 and of course is synchronized with this camera number 5. Then the SPG inside the OB-van, if it is working in free mode means it's generate itself a signal without any external reference, can be connected. This black burst can be connected to the gen lock in of the SPG internally to the OB-van. You press a small button which says, please synchronize yourself on external black burst, and then you have your OB-van synchronized with the EQR1. And you have nothing changed from camera 7 point of view on triax and camera 22 on triax. But camera 5 can be used into the OB-van directly on the video switcher without using frame synchronizer. Because all these equipment now are synchronized. Any question? Okay. Okay. Now, on talk, we have also audio-video monitoring, which is a local system with a monitor which is auto-sensing 12G and HD. And we have also audiometer, which is also auto-sensing 12G HD. That means any information which arrives from externally, maybe from OB-van or from uh, a local video output, can be inserted inside, and then you can see the picture and you can listen the audio, and the monitor tells you if the picture has 12G or HD or whatever. This is just a local monitoring that you can use on inside the talk. This is another particular features that we have on the MediaNet network. So, as you know, we use Dante network to move audio contents from one side to another.
Sorry, Mauricio.
Dante networks, it works over IP.
Mauricio, we have one question, please.
Oh yeah,
Can we synchronize EQR1 to the Obi-Wan? It means Obi-Wan will be the master and the EQR1 it will be the slave.
in theory yes, in practice not, because I mean, of course, the EQR1 has external genlock in.
Yes.
So let me try one thing. Okay. If you look at the rear of the leader, wait a minute. On the rear we have, if I remember well, is in position. There is a BNC, which is gen lock in. We have a changeover, and then we have another SPG, which is a secondary one, with its own gen lock in. Let's call it GL. On this side, there is a small RF BNC which receive, not send, receive a GPS signal. Okay, now on the front of the machine there is a small control board. Then you can say to the machine, use, to the SPG, use this one as general synchronization system, or move on genlock. There is no any error if you bring two cable from the Obi-Wan, and with one cable you arrive here, and with the other cable you arrive there. But in this case, when you exchange between GPS to that one, all the area in who belongs to the EQR1 means prayer hall, esplanade, minaret, garden, bâtiment M, yeah, I think that's all. They are in some way synchronized. If there are some device, active device, maybe in the minaret we have, and the bâtiment M we have, and the prayer hall we have the camera. all this area will be synchronized by the gen lock from the OB-WAN. But as I told you, there are some devices into the EQR1 which also controls device in EQR2. But EQR2 in this case still use with the 2SPG the signal from the GPS. That means EQR2 and EQR1 will not be synchronized no more. That means maybe on MediorNet we may have a problem, synchronization problem on the send and receive video. And generally speaking, the gen lock used in EQR1 and EQR2, which is locked to GPS, is more precise than the gen lock used local, or it's a free. Technically, this one is in free run. That means the precision of the and stability of the system is related only to the internal oscillator of this equipment, which generally is good. Yeah, of course, it's good. But in this case, the black burst and the reference signal generated by this equipment in EQR1 are not related to the quality of the internal oscillator, but are related to the GPS signal, which is perfect. It's atomic clock. Of course, if the OB-WAN has its own GPS receiver, which lock the internal SPG, well, the quality of this lock it's perfect, as we have here, because they refers to the same type of GPS signal. But in any way, even in this case, you have to try, because if you are with the OB-WAN in the same position that we have the antenna in our system, it may be possible that in this case, the OB-WAN will supply a gen lock in, which is referenced also for EQR2, and the two system still in synchronization mode. If this one is free run, not, and can be a problem. Any question?
Thank you.
I think, let me check. Yeah, I show you one thing, just a second. This is from, is visible, yeah. Okay. This is a conditioning of the, this is micro and UHD, and this is Compact Pro. Are slave because they receive a signal, and this one is master locked. And as you can see, we have a black burst PAL at the output. And of course, the TOC Compact Pro, you can see my cursor, this point, we have blackburst PAL output. And this blackburst PAL can be used to synchronize anything else. Any question?
I
Omar?
think it's okay.
Okay, perfect.
Thank you.
So let's back on the yeah on the Riedel RockNet system. Well, Riedel RockNet system is an internal system in Riedel MediaNet which allow the system to um, transport audio channel from getting it from analog interface. We have analog interface RockNet in AQR1 and Riedel analog interface also in Taco Bivan system. There are one device which is input audio with 8 analog input and two device with 8 analog output audio. These audio are analog. That means we have a capability in talk system to receive 8 analog audio in, maybe from the OBVAN, and send to the OBVAN 8 analog audio output separated, plus other 8, means 16 channel audio from talk or from AQR1 or from GMA to the talk to the OBVAN, and GMA can receive 8 analog audio in from the OBVAN. When we talk about the audio on the Riedel MediaNet, is not just related to the AQR1 or the prayer all, because as we have already seen in the other days, the system MediaNet is overall. So on this two output, I can have a microphone from auditorium, or on we have two microphone auditorium. I have one output here, one output there, which goes to with the audio cable, of course, in analog mode to the OBVAN. From audio point of view, analog audio, we don't need synchronization because audio itself, analog, is not synchronized. Does not contain a synchronization. Um, it's better if I use the Marco, please, can you switch? Thank you. Come on. Okay. If you remember, we have AS. No, let's do another way. We have audio packet 32-bit. And if you remember, we saw that with the audio packet 32-bit, we need a synchronization signal, which is more or less like this one, which is a 48 kilohertz. at TTL level, means more or less 5 volts. Every time we have NAS packet, we have a change in the square wave. So this is not drawing correctly, but should be in this way. It's not drawn correctly, yeah, but okay. Then we start with another packet here, and this packet will end here. So this is the reason why we have to distribute word clock with the digital audio AS and more. If we want to put this audio over video, video also is a stream with a packet of data, and we have some position called ancillary data, where we can put anything we want in terms of digital signal. And we used those ancillary data to put the audio information. Let's consider that the video information is so big respect to the audio information. But of course, our video information is locked to the reference. If the audio is not locked to the reference, we need a certain device which keeps the first bit and put the bit where? Somewhere here or somewhere there, we don't know. If the 48 kilohertz is synchronized with the reference, we have a synchronization relationship between the position of these bits, ancillary data, and the audio. Then we can put directly the audio in the right position into the video. Otherwise, you get an error, which is audio applied to be applied, not synchronous. To avoid that, we have a word clock and we have the video from the same source with the reference and the word clock from SPG. This is the reason why we use SPG to generate word clock and blackburst reference to get everything synchronized, and then we know automatically where to put the audio bit inside the video bit. It's embedded. This is not a problem with the analog audio, because analog audio can be also maybe a sine wave, 1 kilohertz. This sine wave is analog signal, has no bit where to put it. What happened is we have a sine wave, we have an A to D converter, which converts this sine wave in a series of bits, and this converter should receive a clock from word clock or from, there are some converter which there are three type of signal. Some converter use word clock. Some other use DARS, and some other use a reference blackburst. The rate of the conversion is locked to the external clock, and the external clock is locked to the SPG. That means doesn't matter if the sine wave is locked or not to something. What it is important is the conversion in digital is locked to our system. Word clock, use it as a clock. Digital audio reference source, it's a AS signal without any signal inside, or blackburst reference. So the device from Riddle Rocknet, which has audio analog input, it may receive on this input this sine wave, but through the MediaNet, this device receive a clock, and the conversion of this analog in digital is absolutely synchronous with the system. This is why we don't care about synchronization for audio respect to the system. What we have to take care about audio is delay between audio and video. Because every time we process a video signal, we introduce a delay. If you remember before, I told you if you use a frame synchronizer, you will add a delay of 1 frame. If you go through the video switcher, you will add another frame. The transit over the router does not add any delay, if I remember well, but through the video switcher we have 1 frame delay, I'm sure. That means if you receive the audio here, if you send the audio here or you receive the audio from analog and video, then it may be possible that you need to synchronize in terms of delay, not synchronize in terms of signal, video and audio to get the same delay and have a good sound in the right position of the picture. Any question?
It's okay.
Okay, perfect. Please, Marco, can you exchange on? Yeah, thanks. So this means this audio that we get out, in, and audio that we can send out are analog and then can be sent directly to the OB1 if we need. Through the RockNet, and through the RockNet interface on MediaNet, this audio can comes from everywhere. EQR1, EQR2, Auditorium, Minaret, or whatever. Yeah, there is one point which is important, and it's better to check it. Please, Marco, can you change on the? If you have a triax with a camera, and you want to do an interview, then uh, there are two ways. First, you connect your microphone directly to the camera. Normally, each camera has a microphone input. Then the audio goes through the triax and arrive to the CCU inside your BVAN. Then you can extract the audio from audio output and goes to the audio mixer. Or you can use another connection which is available on the wall box, can be the core duo fiber with a converter, audio converter from maybe microphone to fiber, or it may be possible to use a fly case with some analog audio input on the Compact Pro on which you can connect your microphone and then send through the MediaNet the signal to the RockNet interface in TOC and then get out with analog to the OBVAN. In this case, 99% your audio, there is no audio delay respect to the video because is managed by the camera itself. In that case, video follow a different path respect to the audio, and audio has also a lot of processing. That means when you receive audio here into the OBVAN, it may be possible that you need to advance or delay audio respect to the video or delay video respect to the audio to match the correct lip sync. I have a picture, maybe. Oh yeah, this is a picture about the MN Compact Pro in EQR1. Yes, where we have audio and yeah, from MediaNet point of view, all channel are MADI, multiple audio device interface, but we call it RockNet interface. MADI is just another name, another way to transport audio, a large quantity of audio, 64 channel each time from one side to another. If you're interested, Marco will show you this interface directly inside into the EQR1. Okay. So yeah, any question? No question? Hello?
It's okay.
Okay. Omar, what do you think? We may have a break now.
Yes.
Okay. Thank you.
You're welcome. Thank you.
Okay, welcome. We can
Thank you.
continue.
Yes.
So the next device that we have in talk Obi-Wan is a Dante interface. Um, this is Rio 16008, and from a functional point of view, it is exactly the same to the Rio 3224. Of course, this one has is smallest respect the other, and 16, the number 16 here is the number of input channel, and 08 is the number of the output channel. There are two interface Rio in talk connected on Dante network, primary and secondary. Uh, it's important to remember that if Dante primary will fail, Dante secondary will take over, and then we have a continuity of audio input and audio output, of course. This device can be attached, so it's from electrical point of view is attached to Dante primary and Dante secondary, but there is another level which is the logical point of view, and the device can be attached to another Dante device on the same network that can be one of the audio mixer in EQR1 or in EQR2. And this give us a great, a lot of flexibility, because you may have this interface number one connected to the audio mixer in EQR1, and the other interface, because we have two Rio, connected to the audio mixer in EQR2. Through this Dante interface, you can send and receive audio, and the particularity is that if you act this small button, which is plus 48 master, in this position is in on position, you can select on each input the phantom power for the microphone. That means you can use on each input a microphone, a condenser microphone, which require power to work, and each input is able to do it. Well, you can connect a dynamic microphone without power, a condenser microphone which require power, or each input can be used as line level, plus 4 dBm. Just to give you an idea on how about the flexibility of the interface, Marco, please, can you switch? Okay. This is the amplifier input of the system. Then we have a connection. If line level is plus 4 dBm, which means, roughly speaking, around 1.2 something volt. This is line level. Considering that 0 dBm, 0 dB, which is the base, it's 0.775 millivolt. 0.7 volt. The input can be switched also to microphone input, which is a minus 60 dBm, which more or less 1 millionth of a volt. It means 2-3 microvolt. So as you can see, the system has a very wide range of work. Be careful, because every time you connect a signal to the system, you must know if the signal is a line level or is a microphone level. Because if you connect a microphone level device to a line level, simply you have zero signal here, because this one is too low respect the sensitivity of the input. But if you connect a 1.2 volt to the input, and your input is adjusted to be 2-3 microvolt, then you overload the input, and of course it is made possible that you will damage it, because you supply to the input one signal which is 1 million times greater than the signal that will be. This is an important point where to uh, keep an eye, keep attention on it. Any question?
It's okay.
Okay. In talk, we have a switch, which switch is um, on the same network of the general switch that we have in EQR1, and we have some VLAN installed, VLAN for Everts, VLAN for Riddle. Okay, for Everts, we use the VLAN to have a router control system, and for Mediornet or Riddle, we have a VLAN to control and use the intercom. Of course, one intercom panel is fixed into talk, because the operator, which is in the technical operation center, in some way has to communicate with a QR1 or a QR2 or a belt pack with the operator in the esplanade or in the garden. But there are 3 additional panels which they does the same function. But why we need the 3 additional panel? Well, really we don't need it inside into the talk. But the characteristic is to let's imagine that you have to Marco, please, can you switch on whiteboard? Okay. Then let's imagine that you have an OB van from national television. Then we have okay. And then again, as usual, we have a camera on column 7 connected through triax. Sorry, this is wrong path. It's not this one. Connected to triax in this way. Talk, because we have a tracks panel here. Then we have another camera, wall box 22 in the garden, connected to the talk, and then we have, okay. Through the tracks camera, usually, is it possible from the Obivan to talk with the operator? There is a headphone on each camera. Then the director here can talk to the operator and said, okay, go up, go down, left, right, zoom in, zoom out, and so on. But if there are other people from television here who needs to talk with the director inside, well, it may be possible to bring one spare panel and put the spare panel into the Obivan. Then these people can talk over the flybox where we have an intercom panel, and then they can talk directly to the Obivan. Or you can put the RSP panel inside the Obivan, and the director can talk with EQR1 or EQR2 directly. So it's a way to extend the internal intercom system to an external Obivan just to have a communication possibility. So, any question? Okay.
Maurizio, please.
Yeah.
For the intercom panel, it's
Yeah.
Ethernet, the connection.
The connection, right, you are right. Yeah, thank you. Yes, thank you for the question. The connection, it's a simple Ethernet cable that can be a 100-meter cable. Yes.
Perfect, thanks.
Of course, the panel needs power, 220, but of course, power can be inside your divan. The real connection is just an Ethernet cable.
The panel can't be powered over Ethernet? Over Ethernet?
No, I don't think so. No. No, I think the RSP 2318 panel does not have these features. No.
Okay, thanks.
No. Okay. So this is the two rack that we have in technical operation center, where, of course, it's easy to see, but just to see together, we have, okay, the fiber patch we will see later. Now we have the Ethernet switch that I told you that we have on it some VPN, VLAN, including management, including Everts, including Riedel. This is the monitor, which can be 12G or HD automatic switch. So if you plug in a signal which is 12G, monitor will show you the picture. If you plug in the video HD, monitor will show you the picture. Just this as a small indication for, I think, 5 seconds or 6 seconds that this signal is HD or 12G. But the pictures appears in any way. There is an audio monitor from Blackmagic, which is also auto sensing. Then means you can apply to it a 12G or HD signal, and in any case you can listen the audio, and there is a very small display where you can see also the picture. We have the fixed intercom installation, useful for the inside talk. Then we have a control, RTR control, which control just one output of the router on one of the BNCs here. Then you can check all signals here. The cable that you can see here is the cable used to connect this monitor. Then we have the first RIO interface, audio interface. We have RockNet audio input and RockNet audio output, 16 output, and the RIO number 2. Well, just in case, if needed, because let's suppose that you have an OB-WAN and you need a lot of channel audio analog from the OB-WAN to the TOC. There are two ways. Or you have 10, 12, 16 audio cable and you connect your system means your OB-WAN to the TOC OB-WAN, or it may be possible also remove this RIO number 2, connect two cable, primary and secondary Dante, and move the RIO temporary inside into the OB-WAN. You have also to use a lot of cable, but instead to have 16 cable, 60-meter long or 70-meter long, you just use cable 1-2 meter just to arrive to the video mixer. This is another possibility. Then we have the tracks panel that we have already seen this morning, and the video patch. On the video patch we have termination which arrives from the micro N UHD, as we have already seen this morning, and terminal from MN Compact Pro device. The audio for the MN Compact Pro device can be connected directly on the Compact Pro. Then we have spare intercom panel that we can use, as I told you, to move the panel everywhere we need, and just with an Ethernet connection we can use the panel to talk with the entire GMA system. I would like to spend some words about the fiber patch panel. So the fiber patch panel is used for essentially for Dante and MediaNet connection. As we have already seen, I think yesterday, maybe, yeah, some connection are fixed. So means we cannot touch this connection, because if we touch it, something happen around the GMA, especially for the MediaNet. And if you disconnect Dante, of course, you lose the control of the RIO interface. But on the panel, there are some spare fiber connected, and this panel is connected directly to the EQR1 fiber patch panel. That means if there will be an event along the project and the preparation of the event, it may be possible that you find that it is convenient to use some optical interface for some reason because you need to add something special. You need to have more channel, audio in, video in, audio out, video out, or whatever. Then keep in account that you have fiber from this position to the same position in EQR1, and those fiber are completely free. You can use it as you wish. As we saw yesterday, we know, for instance, that we have a connection between um, a router EQR1 to the router EQR2. But if you are not using the fiber which connect the output of the EQR1 to the input of the EQR2, then with the patch cord, you can use the output of the EQR1 to go into the Tokobivan system. And then in this position, you can connect a converter from fiber to video, from fiber to video coax directly to get the output, or vice versa. You can send a video here with a converter from fiber from coax to fiber, and send this signal to the input of the router. The connection that we have on the system is an average of the connection that normally will be used. But if along the preparation it's normal, every event has different characteristics, and cannot exist a general configuration that is useful for all the events. Every event is its characteristics, and you need time to talk about the event, understand what the customer wants from the system, and then check the system, and then try to put in place all the connection that you need. Every time connection can be different, but it's not a problem. This is a flexibility of the system. Any question?
Yes, Maurizio, please.
Tell me.
Maurizio, if I understand well, in the GM project, we concentrate about building D and building A, right?
The technology, you mean?
Yes.
Yes.
But we have some wall box everywhere. So my question, if for example in the same time, or we have a tall event for 1 week, 50 days, and there is an event in building A, another one building D, and we need to add one other more event in building D, for example. So
yes.
to add, or we can add the OB1 here like a new EQR3 as an extension using the fiber and connect to the mesh?
It's not a problem. I mean, EQR1 can work completely independent from EQR2. And you may have input output on the technical operation center for EQR1 and for EQR2, but you completely separate always.
Yes, but the fiber is the same in the mesh. For example, we use all our camera in building D.
Wait. The fiber in the mesh is the same, but the mesh is working like a router. That means, let's take for example, micro N in the talk, okay? No, it's easy if we consider, wait a minute, just a minute. No, I'm looking for a right picture, just a minute. This is not the right one. Okay, give me a second. I have to find out the right picture. Just a second, please.
Take your time.
Day 4, maybe. Okay. Okay. Okay, okay. Yes, 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 yes. No, this is not. Maybe this one. Okay. Okay. Give me the right picture. Come on. Okay, this is the right picture. Please, Marco, can you exchange on... Okay, this is the MN Compact Pro. Okay? You can see it?
Yes.
Yeah.
Okay, perfect. So, we have video in, 4 channel, and we have video out, 4 channel. So, if, this device is connected on the mesh read-on mesh, then you can send on the BNC number 1 the program out from AQR1, and on the BNC number 3 the program out from AQR2 independently. And the same time you can have a video, sorry, here. You can receive a program from a QR1 here and the program from a QR2 here. And you can send to the system a video here directly to the QR1 and a video here directly to the QR2. Completely separate. And this is
Maurizio,
valid also for audio.
maybe I didn't explain my questions well. It's not according to the Compact Pro, it's according to the fiber. I mean to add an extension, a separate extension. We use here the Obi-Wan like another EQR3, for example, in building E with others camera, others equipment. But
You
still
mean
using the fiber in the mesh, because we have only one point in the garden, for example.
So just a second, please.
ما عندكش ميكسر.
So, sorry, I was talking with Marco because I have not understood exactly your question. You mean how to extend the fiber where the mesh is not present?
No, the mesh is present. but use it for a third part. EQR1 using their camera and work with event number 1. The cameras in building D also work event number 2, and we need another event in building E, for example. We don't have fiber, and there is no position to get the OB1 there. So, we can use the links in the mesh to send the video signal without get troubles with the other event, because we have only one MPU.
For Walid, for each event, for example, you need the mixer, and we don't have third mixer. How
the
to
mixer,
mix? How to?
It's outside mixer in the camion, for example.
OB1 from UNTV, for example, can operate alone without our system. Only if he needs some source from the other event on the same time.
No. In my question, I need also the link, the mesh link, MPU. For example, we have troubles and we can't get a new cable. If that can.
Yes, of course.
We can use VDI system.
If you don't have fiber connection in the, in the new event, building E or whatever, of course, the first thing is to have a fiber connection. Then you can do anything.
Like we did on the 5th of July, Maurizio.
Sorry, Omar?
Like in 5th of July event, the Algeria Telecom provide the fiber for us.
Yeah, you have to put fiber, maybe from Algeria Telecom or I don't know.
Or the VDI system
yourself,
in the GMA.
And then connect this fiber on the MediorNet link. And then you can attach the interface in the building E, for instance.
So we can't create a new extension in the mesh?
From a logical point of view, yes, but the problem is there are no fiber. So all the points that you see on the general plan, points in the garden, in the minaret, in the esplanade, and so on, we have not decided this point. This is a requirement from the customer. And I know there are some areas without fiber, but that's it. If you want to extend the fiber there, you can do it temporarily using some fiber externally, which can connect. Maybe if you have a location near the building D, near the auditorium, then you can extend with 200, 300 fiber meter where you need it. If you want to extend maybe just for the fly case, you can do it. You need 12 fiber for each fly case. And your point where you can attach to the MediorNet is inside the auditorium, if you are near there. If you are near the prayer hall, you can use EQR1, or you can use a wall plate on a column in the prayer hall. As we have already done for in 22 for the 5 Juillet. It's correct, Omar?
Yes. We can, for example, from EQR2, we pass to special external fiber to VDI system because it's near. And from VDI system, building D, we can pass to building F, for example. And we install the flycast there. Maurizio.
Yeah, yeah.
Thank you.
Sure. No, I mean, I don't know if the answer is good or not for you, Walid.
My idea it's not a separate fiber. I want to use always the. I'm thinking it's just an idea. If it's possible. For example, the mesh. You told us that the connection in the mesh are fixed and we shouldn't touch them. Maybe we can find.
Wait.
Walid.
On
Sorry,
the
Maurizio,
mesh
I can't
panel
answer.
inside the EQR1.
Yeah.
Walid.
Okay.
Walid.
I try
sorry,
to
Maurizio,
do
sorry,
a
1
drawing
second.
just to have an idea. Then we can talk about that, about this drawing. Just a second.
وليد الماش اللي قال لك فيكس كي طلع بار اكزومبل الفوق تلقى لي فيبر اللي راهم كونيكتين مع الماش هذوك ما تقدرش توشيهم سينو يروح لك الميديور نت كومباكت برو ولا.
اني معاك عمر بصح الماش فيه دي كونيكسيون بارتو ياك. لو كان نيزولي ليزون وحده راح يبقى مازالني فياب عندي دي ليزون واحد اخرين. اسكو نقدر نيزولي لا ليزون تاع في بوين بار اكزومبل في الجاردان باش نكوفري البيبليوتيك ونخرج للكاميون ديريكت بلي زيكيبمون اللي راهم في الكاميون بلا ما نيتيليزي لي زيكيبمون اللي راهم في لا ريجي 1 و 2. راني ايزوليت لا ليزون برديت هاد لا ليزون بارابور للبرودكاست بصح اكسبلواتيتها في تروازيام ايفينمون طومبوريرمون من بعد نقد نعاود نكونيكتي. اسكو سي بوسيبل والله لا
معليش راك خرجت الايكيبمون من الماش كيفاش راح تستعمله وحده هذا واش حبيت تقول
نبرونشيه مع ليكيبمون تاعه دونك راح ترجع بارابور ليكيبمون اللي يكون عندكم.
احنا ليكيبمون اللي عندنا ماشي
ديفيرون على هذا.
داكور يقدر يعطيك لي زونطري بي ان سي و اكس ال ار اوديو فيديو. مازال ما عندهمش في الفيتور راح يجيبوا لي كار.
Can you see this picture?
ريجي.
Yeah.
Okay. So the mesh topology is a series of a fiber patch panel in control room A, which is EQR1. We cannot touch this configuration because this configuration is original one from Riedel. And they say you can do this signal in-out with this mesh configuration. But if we are talking about the fly case, those two, we have this 12 fiber, which is a 6-link. But the extension of this 6-link can be anything. Can be 100 meter or can be 200, 500 meter. You know? That means if you have on the garden, you have 6-link which arrives on TP12 in the garden, then you can attach a cable there 200 meter to extend this connection to a fly case number 2, for instance, in bibliothèque or whatever.
But you cannot isolate. تحبيت خوزا شغل تيزولي ايكيبمون بصح الا ايزوليتو من لا ماش لازم لك ان اوتر ايكيبمون باش تكري اون ماش جديده.
هذا هو واش كاني فهمت تسمى تبقى سا ديبون ليكيبمون اللي عندهم هما.
ما تقدرش تا باغ اكزومبل انا نحي هادو تاع الفلاي كاس ما نكونيكتيهمش مع لا ماش برينسيبال لازم لي اون ماش واحده اخرى فيها لي ميم بروتوكول لي ميم زيكيبمون.
علاش اون ماش واحده اخرى علاش ماشي اكستونسيون؟ سيبوزون لو ان تي في عندهم لي ميم زيكيبمون
قلت
هنا
راك ريبونديت الا عندهم لي ميم زيكيبمون.
هذا واش حبيت دونك
عندهم باغ اكزومبل لي ميم زيكيبمون، تنحي ايكيبمون من عندك تعطيه لعندهم، تعاود تكونفيغوري لادريس يكونيكتيو. مي الا عندك غير انت اللي عندك هاد ليكيبمون تنحيه من لا ماش هادي، ما عندكش واش توتيليزي، عندك ايكيبمون مور سي بون سي تو. هذا ما كان
ما يكونش مور باسكو ميم في الدين عندي ليكيبمون هذا باغ اكزومبل في لي كيس راهي في لي كيس ولا ليكيبمون اللي كيفها في الاو وفي الكاميون باش تكون عندي ماش نولي عندي الماش وبوس.
مال يكون عندك دائما شغل اون ريجي واحده اخرى،
فوالا
نقولوا زعما في ستوك توتيليزيه. الا باش تنحي ايكيبمون واحد توتيليزيه ما تقدرش.
ميرسي ثانك يو موريزيو.
ثانك يو ماوريسيو.
Oh, you're welcome. Listen, if there are area which are not
covered
connected with the fiber, it is always possible to put a new fiber from the area to the equator one. Sorry. It's always possible to put the fiber from that area to the equator one on a fiber patch panel, and then, if necessary, you can extend the mesh to that area using maybe a new equipment like a new Micro N or new Compact Pro, or use the fly case. I mean, the Riddle mesh, the Riddle MediaNet system is not a closed system.
Yes, it's open.
It can be always expandable, you know.
but the fiber is limited.
Yes, you can
For
add
example,
the fiber.
to transfer the signal of 10 camera or 20 camera, it's different. What's the limit in our case? How many camera we can send the signal in the same time?
Is written into the picture. In control room 8, you may have 24 in, 24 out 3G.
Yes.
Or HD. With the fly case, you have 24 in, 24 out 3G.
Or 8 in out and
12G.
8
yeah.
output on 12G.
This is the number of channels that MediaNet mesh can handle is written inside with the actual configuration.
Thank you, Maurizio.
Okay. So where we were, no. Okay, minaret schematics. So Marco, yeah, thank you. Minaret schematics is day 3, day 2, day 1. Is it? Please, Marco, can you exchange to the... Yeah, thank you. So, if you go on the minaret at the level 300, you may find 4 camera on the 4 camera on 4 PTZ, PTZ system from Vinten. Camera north, south, east, and west. The configuration of the camera, it's identical one to each other, and the camera are HDCP 43 as usual, connected with two fiber each camera. Then we have a 6-core fiber cable which goes from one junction box to another, and then we have two fiber which goes on the big cable, 24 core cable, and arrive straight directly in EQR1. So means the signal from the camera will arrive directly to the EQR1. I remember you that the Vinten device PTZ required just one network connection to control the robotics. This is the reason why we have just one Ethernet connection instead of two as we should have for Shotoku. And we use the network trunk embedded, as we have already seen in the past, embedded into the camera. So we send the Vinten Ethernet into the BPU on the trunk input connector, and we get out the network Vinten from the camera, and we connect with the alpha meter cable to the PTZ system, and in this way we are able to control the Vinten system. Camera is the power supply for camera is from external with the original PS power supply unit from Sony. There is one particularity is that I forgot to tell you before, but it's better if I tell you now about the Shotoku system. Shotoku system into the micro PDU has a possibility to supply power also to the camera with plus 12 volts output. But the problem is this power is limited to 60 watt. For some reason, there are some moment in which the camera needs 100 watt. Not continuous, but it's a peak. And we have decided to do not use the internal power supply from Shotoku, but use an external one, the original from Sony. On mezzanine, in position 8 and 10, we have two Bolero antenna which use less than 20 watt. And for this antenna, we have used the power supply output from Shotoku. That means if you power down the Shotoku system from the main switch, which is at S10 level, maybe Omar remember where is it. You also power down Bolero system, which is the RF intercom system.
Sorry, Maurizio.
Omar, you remember where the switch?
Which switch? Can you repeat because I was speaking with...
The switch for in the pre-roll mezzanine camera 8 and 10.
8, 9, and 10. Each switch...
8, 9, and 10, yeah.
Each camera have a special switch for the power, for the main power.
Yes, but the main switch are in the middle of the stair to move from RDC to mezzanine.
No. Each camera have a position for the switch, and we have one drawing that have all the position.
Okay, perfect.
Yes.
In any way, please show them where are those switch because it's important.
Yes. No problem.
Okay, thanks.
You're welcome.
So, um, this is how the camera on Vinten system will arrive to the EQR 1. This is the connection with the 24 fiber here and 24 fiber there to the EQR 1. Even on the minaret, we have micro N UHD node 2 and MN Compact Pro node 3, which are interfaced with a BNC panel, and in the minaret rack, if you want, you can connect some video sources or video monitor, depends what you need, to send and receive video in 12G or in HD as you wish. Of course, MediaNet is, as we have seen before, in some way, a video router. Then means if I send a video in here, if I connect a camera here to to insert a video in input A8 of the micro N UHD, this video can be sent to EQR 1, EQR 2, or directly to the TOC. It's a routing system. Of course, independent mode from all the other system. That means you may have the micro N, which send and receive video from EQR1, and MN Compact Pro, which send and receive video and audio from the TOC, as you wish. Any question?
I have a question, Maurizio, from the ENTV about the Bolero.
Bolero, yes.
Yes, the belt pack. They want to know if we can know which frequency, radio frequency, the Bolero use to provide this information to the security, military security. For example, if the president will be here on this event, to do not disturb this frequency.
Yeah. To be honest, I don't remember, but I think it's easy to check it.
To check it directly. Maybe Marco can help us on this information.
Yes, I think it may be possible to check through the menu.
Okay.
I don't remember in this moment, to be honest.
Afternoon, we will check with Marco. Thank you.
But with Marco in the menu of the system, in the settings, it's easy to find out it. Really easy. And so, other question?
No, it's okay.
It's okay. Perfect. Okay. Sorry, something happened. Yes. Oh, please, Marco, can you exchange on the other source? Okay, thanks. Okay. Now, this is a fly case. Maybe you have already saw one, but in any way, this is a fly case where we have a Riedel intercom system, before that, sorry, before that, the system use the MediaNet, and we have already saw that on MediaNet we can send video, audio, and we use MediaNet also to distribute embedded Ethernet network. Of course, micro N UHD and the Compact Pro are working on the MediaNet mesh. That means it's normal to have those equipment connected on the fiber. But inside into the fly case, we have also other equipment like this Rio and this Riedel intercom panel that they are working on a different network, not on the MediaNet. But the fly case is connected just with 12 fiber on MediaNet. In this case, we use the embedded Ethernet channel to transport Dante network and Everts, and Riedel intercom panel network. To have the intercom connection and Dante connection. These cable that you can see here, fiber, are 4 plus 4 fiber connected directly on the back of the micro NUHD. This 8 fiber realize a connection of 100 gigabit per second. On the micro N, we have some video connector, but are on the back. This is the reason why on the fly case there are connector here on the front connected directly to the micro N. The first 4 connector are 4 connector 12G in for the micro N UHD, and the last 4 connector are 4 connector HD in for the micro N UHD. Then we have 4 HD connector on the MN Compact Pro in and 4 HD connector on MN Compact Pro output. That means you may connect a video camera here or here to send the video through the MediaNet. At the same time, you connect a monitor on the fly case and receive video from this line or from one of the other line and connect a local monitor on the fly case just to have a video return. Again, this Rio 1608 is exactly the same that we have already saw in talk, and you may connect at the input here anything you want, including a microphone. Then if you connect a microphone and then you have a camera connected there, you can use the fly case to do an interview, and the signal, audio and video can be sent directly everywhere, EQR1, EQR2 or talk. Microphone can also be connected on the audio input of the MN Compact Pro, but in this case the audio will travel not on Dante network but on the RockNet network, and will arrive maybe in Talk of Ivan and you can extract this audio maybe on this equipment. This can be the audio output of the input that you have on the fly case. As I told you, MediaNet essentially is a way to transport signal from one side to another, but inherently it's such a big routing system where you can send audio, video everywhere where you want. There is one feature for MediaNet which is very important, is if you connect a microphone here, then you send audio on the Compact Pro, you can extract the audio from Riddle Rocknet here, but the audio itself inside the MediaNet system can be also embedded into the video. So Riddle MediaNet works also as embedder. Then if I put an audio here, I can have the audio extracted on the MN Compact Pro, the audio embedded on this video as the I output in the talk. So the Rocknet does not work only from Rocknet in to Rocknet out, but also what is input in Rocknet can be embedded and outputted as audio embedded on any video that it is available on the MediaNet system, HD or 12G. Is it clear? Omar?
Yes.
Okay, thanks. Now we have a fly case schematics. Okay. This is a fly case schematics where, okay, we have this micro NUHD and maybe I have the info about the frequency of the Bolero. Just a second, please. Oh, sorry. Okay. No. Okay. This looks to be the technical specification for Bolero. If you want to take a note.
La fréquence.
Is
عندها
it
une
clear?
plage. دونك لا سيكوريتي تعطيهم هاد لا بلاج ما ينحوها من البريور. لا غالب. Thank you, Maurizio. Thank you, Marco.
It's okay?
Yes.
Okay, perfect. So, yeah, we were talking about the micro NUHD, which has 6+6 fiber to connect the MTP12, and we have also on QSFP4 a connection that was the connection that I show you on the yellow cable, which connect the MN Compact Pro with 100 gigabit per second to the MediaNet micro N UHD. Then we have a series of SDI output, SDI input, and audio in, audio out, and we have an Ethernet connection, embedded Ethernet connection to the reader control panel for the intercom, and two Ethernet connection, Dante primary and Dante secondary, for the Yamaha Rio. Fly case cannot be powered by batteries, but they need external power. This is the reason why in each wall box, floor box, wall plate, together with video, audio, and fiber, triax and CPT connection, there are also two sockets for power to power the fly case or any other equipment. Into the schematics, we have into the schematics as example, we have included also what can be a future expansion, that it is represented by two radio microphone with a two channel each, that if you want to put in place, you can connect those microphones directly to the Yamaha Rio in from 1 to 4. Then your fly case may have uh, a wire microphone connected from 1 to 4, or from input 5, 6, 7, whatever you want. Or if you have a radio microphone station, you can connect the radio microphone directly on the input 1, 2, 3, 4 line input, of course, because the output of the station is line out, is not microphone output level. And then you may install a radio microphone also in the fly case. Any question?
Okay.
Okay. And now we can see. Please, Marco, can you exchange? Yeah, thank you. We move to the edit suite and archive. So now we have to go back 2 or 3 days ago to remember what we have already seen, and then we can you can understand better everything. So if you remember, 2 or 3 days ago, we saw the PWS 4500 machines. And I told you that each PWS should be connected to its PR1 controller. So in EQR1, we have 2 PWS and 2 PR1 controller. But exists also in EQR1 another computer which is related to the PWS, which is 110 MG1. This computer contains a software which can go inside into the file system of the PWS without stop the functionality of the PWS. Let's say if this one is in recording mode for an event, this PWS 110 mg1 can go inside and read and write file without interrupt the system. This device is intended to be a file manager computer. So if the peer one will manage the machine, which video, which audio, where to put in play the machine, put in record the machine or whatever, which audio I want to use, AES or embedded or something else, the MG1 just manage the file inside the machine. And through the MG1, you can collect the file and tells to this machine, send your file number XXXXX through the media network files to the main storage. Here we have also the SharePlay network, which allow the exchange of content very fast from one PWS to another. So on this one, I can put in play that one, and the output of this one in play live show me the contents inside here through the SharePlay network. I remember you, it's a double 10 gigabits network. But through the MG1, we move file offline, not for live video, but for storage and file management purposes. The management of the files has been performed by the archive system, which is a server plus a workstation, and we have two editor workstation which are not related connected to the archive system. I mean, edit can receive video and audio or files from everywhere. Then they can edit files, edit the contents, and the output can be sent in file form to the storage, or the edit has the video interface which can be put in play, and this output can be sent everywhere because it's video. In Edit 1 and Edit 2, we have two computers, and each computer has a video interface board which accept 12G or HD input and give us 12G or HD output. So what does it mean? It means that the editor workstation can be used offline to finalize a product, but they can be used also online because they can be used as a normal recorder, then can record a program or can supply us to a video content to put in broadcast system. Any question?
It's okay.
Okay. Oh yeah. Now we have edit sheet schematics. Yes, of course. Absolutely yes. So this is the edit suite schematics, and as I told you, we have the edit computer with 12G in, 12G A and B in. This 12G can be also HD, of course. And on this 12G A in or video in, we have a router output 15. The SDI output of the edit computer number 1 goes to the video switcher input 11 to the video mixer, and the output 2 goes to the Everts router input 11. So you can, if you have some video materials on this computer, you can put it in play. The play signal video goes into the router in EQR2. Then you can send this video through the router interface on fiber directly on the router inside in EQR1. And then you can put this machine in Edit Suite 1 in play, and you can use the video content in EQR1. The Edit Suite 1 computer has a reference input from the station. That means the video which arrives from Edit computer to the EQR1 is synchronized with the entire system. Then you don't have a problem. You can feed directly the video switcher in EQR1 with this playout without any problem. The edit computer receives also a time code in from the station. That means if you want, you can have on the edit computer a time base, a line time base, absolute referred to the time of the station. There are some other device like monitoring just to see the output, and audio speaker control volume, and the 2 data display to control the workstation, of course. There is also a PWU2, which is a optical disc recorder, which allow you to send and receive video from the PWU2 device. Edit suite number 2, as you can see, this is number 1. Now we have number 2. It is identical. And we have also an audio AS in 2-channel digital audio and 2-channel digital audio output. This digital audio is terminated on the patch panel in audio room. Again, the system is referenced to the general reference. This means this digital audio, which is also referenced through the word clock to the system, is synchronized, and then we can record a video and audio from AS1, and the two signals are in any way synchronized. We never get the error that I told you, audio applied not sync, because this audio in and this video in are synchronized. Any question? Okay. And our last slide is regarding to the ODA long-term storage from Sony. ODA, it's a wonderful product, and into the archive system there are two devices like this one, which is a desktop model, and it is connected in USB to the workstation. If I am right, this USB should work at 10 gigabit second, if I am right. I don't remember exactly.
USB 3.2, 10 gigabytes
It's
per second.
3.2, yeah,
Yes.
yeah, sure. And there are a certain number of 5.5 terabyte cartridge. This one will be inserted here and can be write, but once you have write, you cannot delete it. In other words, this disk is write once. You can read many times, there's no problem, but it's intended not for a temporary backup. It's intended for long-term storage. So you write on the cartridge, then you have to be sure that after 10 years you can read again the cartridge. This is assured by the optical disk archive technology. And the most important thing that no one can change the content of the disk, because it is not possible to delete and write again. Is write once, read many. Of course, you can always destroy the disk, but you cannot delete it. The speed of the disk is so high that allow you, when the disk is inside, you can put in play the content without first reload the backup. So what is inside in terms of video content can be put in play directly from the disk, because the speed of this disk in terms of data rate is so high and allow you to play out the contents. Any question?
It's okay.
It's okay. So this was the last slide, and today we will finish our training course. And well, I would like to thank you to have followed me in these 5 days. The principal aim of the training course was to give you some key to read and understand the system. But on the other side, my aim is to give you some idea about the system, and maybe you have a lot of questions to ask and to develop. The only way is go inside into the system and bring the schematics, bring the manual of the equipment, and try to discover and study what happened and is going on. So that's it. Thank you very much.
Mr. Maurizio, I want to thank you. It's a pleasure for us to spend the last 5 days learning and discover a new field for me especially.
Yeah.
And it was not enough for us 5 days to learn and discover such complexity in the system, and it was vast information for us. But I would thank you and thank you for your effort.
You are welcome. You are welcome, and I'm sure if you have a question, if you have any idea or any question, please ask to
Oh,
Marco, ask to Omar, ask to the people there, and I and them, if we can try to answer to your question.
I will. I will.
Okay?
Thank you.
Okay. Thank you
Thank you.
very much.
Thank you.
Bye.
Thank you,
Bye.
Bye
Maurizio.
bye.